Hi guys, welcome back to Interest Rates. In the previous videos, we have discussed on the determinants of interest rates, which includes production opportunities, time preference for consumption, inflation, and risk. We have placed these determinants in equation form. That is, R is equal to R star plus IP plus DRP plus LP plus MRP, where R star is the real risk-free rate, the interest rate that would exist on a riskless security if no inflation were expected. IP is the inflation premium, a premium equal to the expected inflation that investors add to the real risk-free rate of return. DRP is the default risk premium, a premium added to cover the possibility that the borrower will not pay the scheduled interest or principal payment. LP is a liquidity premium, a premium added by lenders to reflect the fact that some securities cannot be converted to cash on short notice at a reasonable price. MRP is the maturity risk premium, a premium to cover interest rate risk, also known as price risk. Now let us explore more on these principles in the following case. Case 3. A 5-year treasury bond has a 5.2% yield. A 10-year treasury bond yields 6.4%. And a 10-year corporate bond yields 8.4%. The market expects that inflation will average 2.5% over the next 10 years. That is, inflation premium for 10 years is equal to 2.5%. Assume that there is no maturity risk premium, MRP is equal to 0, and that the annual real risk-free rate, R star, will remain constant over the next 10 years. A 5-year corporate bond has the same default risk premium and liquidity premium as the 10-year corporate bond described. What is the yield on this 5-year corporate bond? To answer this question, note that we assume that MRP is equal to 0. In other words, the maturity risk premium does not exist. The investors in the market do not consider interest rate risk to be something of concern. As a result, no MRP is being incorporated in these bonds. This may be true under assumptions of pure expectations. Pure expectations theory assumes that maturity risk premiums do not really exist. What we can see as a differential among interest rates are just due to differences on the expected interest rates in the future. More likely, the difference may be caused by inflation, but there is no maturity risk premium. To answer this question this time, we are going to assume the following formula for the interest rate of the 10-year corporate bond, R sub C10. This is equal to R star plus inflation premium for 10 years plus DRP plus LP in the absence of a maturity risk premium. We know for a fact that R sub T10, the rate of the treasury bonds, 10-year maturity, is equal to R star plus IP for 10 years only. Treasury bonds again do not have default risk premiums because the government is not expected to go bankrupt, and hence the government is always expected to make good of its future promises. There is also no liquidity premium on government bonds due to the fact that government bonds are acceptable by everyone. What we're going to do is an elimination method where we are going to deduct R sub T10 from R sub C10. Doing this elimination method will remove the common variables like R star and IP sub 10. So R sub C10 minus R sub T10 is now just equal to DRP plus LP after eliminating the first two terms. We know that R sub C10 is equal to 8.4%. R sub T10 is equal to 6.4%. This is equal to the sum of the default risk premium and the liquidity premium of the 10-year corporate bond. So this will be equal to 2%. Now that we know the DRP and the LP combined of the 10-year treasury bond, we can also assume that this is the same for the 5-year corporate bond, as it is being assumed in the problem. R sub C5, we know that this should be equal to R star plus the inflation premium for 5 years plus DRP plus LP. But we know for a fact that R star plus IP sub 5, that is the inflation premium for 5 years, would be equal to the 5-year treasury bond, which is 5.2%. So since R star plus IP sub 5 is equal to R sub T5, we know that R sub C5 is equal to R sub T5 plus DRP plus LP. Hence, R sub C5 is equal to 5.2% plus 2%. R sub C5 is therefore 7.2%. There you go. R sub C5 is equal to 7.2%. So that would be enough demonstration for this video. Now let us proceed to the next topic. I would like to talk about the term structure of interest and the yield curve. The term structure of interest rates describes the relationship between bond yields and maturities. Meanwhile, the yield curve is just a graphical representation of this relationship, a graph showing the relationship between these bond yields and maturities. So, when we are going to talk about the term structure of interest rates, we have two axes in this yield curve drawing. On the y-axis is the interest rates. On the x-axis is the maturity. So, I would like you to imagine the following graph. We have on the x-axis the treasury bonds maturity. On the y-axis, we have the market interest rates for these kinds of bonds. Note that in this graph, we have for 1-year treasury bills, 2%, 3.5% for the 5-year treasury bonds, and 4% for the 10-year treasury bonds. Note that this curve is upward sloping. We call this the normal yield curve. Why is this considered normal? Well, we all know maturity risk premium. As the maturity of the bond increases, the exposure to interest rate risk also increases, as discussed in a previous video. To compensate investors who are holding on to long-term securities, such as 10-year treasury bonds, we are going to add a maturity risk premium. And this explains why the longer the maturity of a security, the higher is the expected interest rate. This is the normal yield curve. On the other hand, we also have the hump yield curve. This happens when the 5-year treasury bonds have higher interest rates than the 1-year treasury bond, as well as the 10-year treasury bond. As you can see, the curve is actually hump. On the other hand, we have a downward sloping yield curve when the 1-year treasury securities has a higher interest rate than the 5-year treasury securities, and the 5-year treasury securities have higher interest rates than the 10-year treasury securities. So, what is the explanation why sometimes the yield curve becomes hump, sometimes it is downward sloping under abnormal circumstances. This happens when the inflation premium for longer term securities are lower than those of the short term securities. Okay? A downward sloping curve happens when the long term interest rates are lower than the short term interest rates. This is due to the fact of the expected inflation. Lower expected inflation in the long run will cause the inflation premium to become lower, and hence interest rates will be lower. Now, if you are a fan of the Phillips curve, you know that inflation rate and the unemployment rate are inversely related. As a result, lower inflation rate in the future is associated with higher unemployment rate. Thus, a downward sloping yield curve can be an indication of an incoming recession. So that would be it for our discussion for this video. Thank you for listening and see you in our future videos. Like this video if you find this helpful. Hit that notification bell to be updated for future videos.